Hello friends, welcome to Engineering Funda family. In this video, I'll explain you binomial array with great clarity. Before I start with explanation, let me show you how many things that I'm going to cover in this video. See, first of all, I'll be discussing about basics of binomial array. After that, I'll be discussing about how one can do calculation of resultant pattern using pattern multiplication. And after that, I'll explain you how to have resultant pattern of 3-point sources using binomial array and how to have resultant pattern of 4-point sources using binomial array. After that, I'll be explaining you Pascal's triangle for binomial array, and at last I'll be discussing about parameters of binomial array. So let us initiate this video with first agenda, that is basics of binomial array. Binomial array is non-uniform magnitude array, means with different element of antenna, value of current is different. So here we have binomial array, that is non-uniform magnitude array, and magnitude of element that is there as per Pascal's triangle. Let me explain you how. Here what I'll be doing is I'll be considering number of elements with antenna. So here you can observe I'm writing number of elements, right? And now I'll explain you how magnitude of current is there with elements. So as if you have one element, then here magnitude of current is 1 over here. If you have two elements, then you will have to form triangle. So here we will be having 1, here we will be having 1. Now we have formed triangle over here. If you have 3 elements, then 1 will come here, this one that will come here, and in middle you will have to add these two elements magnitude. So 1 plus 1, that will be 2. So in 3 element, current distribution will be as per 1, 2, 1, right? In 4 element, see this 1 will come here, this one that will come here. Here magnitude will be addition of these two, that is 1 plus 2, 3, and here magnitude will be 2 plus 1, 3. If you talk about 5 elements, then this one will come here, this one will come here, and this element will be addition of these two, that is 1 plus 3, 4. This element will be 3 plus 3, 6, and this element will be 3 plus 1, 4. So here, see magnitude of current with different element, that is different over here in binomial array. That's why it is non-uniform magnitude array, right? It is happening as per Pascal's triangle. And because of this non-uniform distribution of current, you will be observing with binomial array, we have 0 side lobes, or you can say we have no minor lobes over here with radiation pattern. That even I'll be deriving in this video, right? If you have n element binomial array, then electric field is given as per E of t is equals to cos to the power n minus 1 pi by 2 cos theta. And this electric field that is happening as per spacing between two elements is lambda by 2. If you have two elements, that is aparted by distance d is equals to lambda by 2, then one should know electric field because of two element, that is 2e naught cos of pi by 2 cos theta, right? So for two element, this is what the electric field that I have already derived in my earlier videos. Now based on this concept of spacing lambda by 2, if you have n element, then cos to the power n minus 1 pi by 2 cos theta, that is how it is happening. That even I'll explain you by derivation, that will give you more clarity, right? Now what I'll do is I'll explain you how to identify radiation pattern by pattern multiplication, in which I'll be considering 4-point sources. Pattern multiplication of 4-point sources is already covered in this video lecture series of antennas and wave propagation. But to explain you how exactly binomial array is getting formed, I need to explain this problem again. So here we have 4-point sources. You can observe these are the antennas. Those are 4-point sources. We are deal with to identify resultant pattern using pattern multiplication. So in pattern multiplication, first of all, we need to give numbering to these elements. So this is number 1, this is 2, this is 3, and this is 4. Now here in pattern multiplication, first of all, we need to form a group of 2 elements. So here 1 and 2 is forming element that is X, and 3 and 4 that is forming element that is Y. Here spacing between X and Y, that is lambda over here. See, X is placed in the middle of 1 and 2 and Y is placed in the middle of 3 and 4. So but obviously spacing between X and Y, that is lambda over here, as per lambda by 4 plus lambda by 2 plus lambda by 4. Right. Now we are deal with to apply pattern multiplication rule to identify resultant pattern. See, resultant pattern over here is unit pattern of X or Y into group pattern of X and Y. Now how to identify resultant pattern here? By multiplying unit pattern of X or Y into group pattern of X and Y. Right. If you observe, see this unit pattern of X, that is happening based on group of 1 and 2, where spacing is lambda by 2. So here we have spacing lambda by 2, right? We have spacing D, that is lambda by 2, with unit pattern of X or Y, and with group pattern of X and Y, spacing is lambda. So here spacing D, that is lambda. Now we need to draw this individual patterns first. After that, I'll explain you multiplication, right? So here, as if you want to draw unit pattern of spacing lambda by 2, then first of all, you should know nulls are there at angle 0 degree and at angle 180 degree, right? So nulls locations are happening like this, and here spacing D is equals to lambda by 2, right? So that radiation pattern, that will be appearing somewhat like this, right? That is what unit pattern as per spacing lambda by 2, right? Now see, if you wanted to have group pattern of X and Y, then spacing is lambda. So as if you want to have spacing D is equals to lambda, then first of all you need to draw location of minimas. See, with spacing D is equals to lambda, location of nulls, or you can say location of minima, that is there at 60, 120, 240 and 300 angle. So here you see I have plotted minima angles. Now I need to have lobes in between this nulls. So radiation pattern, that will be happening somewhat like this, right? It will be happening somewhat like this. Once we have unit pattern and group pattern, we need to do multiplication of these two, that is resulting into equivalent pattern, that is resultant pattern of this, right? So as and when you want to plot resultant pattern, you need to draw all the nulls first. So here nulls are happening at 0, 180, 60, 120, 240 and 300. Now here I have plotted all the nulls. Now to multiply these two, you see here we have maxima, here we have maxima. So maxima into maxima is resulting into larger lobe. So I'm plotting larger lobe over here. Now you see here we have minima and here we have maxima. So maxima into minima, that is resulting into smaller lobes. So I'm plotting smaller lobes over here, right? So 4 small lobes are there if you have 4 point sources. Now with these 4 point sources, current distribution is I. Current distribution is I, and that is uniform with all the elements, right? That is uniform with all the elements. That's why with this radiation pattern, we have issues of side lobes, or you can say we have issues of minor lobes. You see, these are the minor lobes. These are the minor lobes that we have, right? Now to eliminate these minor lobes, we are using binomial array, in which we use non-uniform current distribution. Here, if you have uniform current distribution, then radiation pattern that is happening somewhat like this. Now, in binomial array, how we apply current distribution, that I'll be explaining you. And to explain that, I'll be considering 3-point sources with binomial array. Let me explain you how. In binomial array, current distribution is happening as per Pascal's triangle. If you talk about 3-point sources, then here, if I draw 3-point sources, this is point 1, this is point 2, and this is point 3. Then here you will be observing with these 3-point sources, current distribution that is happening as per I, 2I, and I. And that I have already explained in my earlier section. For 3 element, current distribution is as per 1, 2, 1. Right. Now, question is how it is coming. See, in binomial array, we have no minor lobes, and that one can have as per this current distribution. Now, question is how it is happening. Let me explain you how. See, if you talk about 4 elements, then see in 4 elements, what we were been doing? In 4 elements, we were been having spacing over here. That spacing was lambda by 2 with each element. Right. Here spacing was lambda by 2 with each element. Now here, if you see, this is element 1, this is 2, this is 3, and this is 4. Now to have resultant pattern, we were been taking group of 1 and 2. So group of 1 and 2, that was happening somewhere over here, and group of 3 and 4, that was happening somewhere over here. And here resultant spacing, that is lambda over here. Right. So if you multiply lambda by 2 and lambda spacing radiation patterns, if you multiply lambda by 2 and lambda spacing radiation patterns, then you will be having minor lobes. But if you multiply lambda by 2 into lambda by 2 radiation pattern, then you can avoid issues of minor lobes. Let me explain you how. See, instead of you take group like this, what you can do is you can take group like this. You see, this is element 1 and 2, this is element 1 and 2, and now you see element 3 and 4 that I'm taking over here. Right. Now see here, spacing is how much? Spacing is lambda by 2 only. Here spacing is lambda by 2 only. Right. Now if you take group of 1 and 2, if you take group of 1 and 2, let us say that is X. And if you take group of 3 and 4, so that will be Y over here. So in between X and Y, if you observe spacing, so that is lambda by 2 only. So resultant pattern is how much? Resultant pattern is unit pattern of X or Y into group pattern of X and Y. So here previously we were been having spacing lambda with group pattern of X and Y. Now we are having spacing lambda by 2 only. So if you have spacing lambda by 2, in that case you will be multiplying this radiation pattern with this radiation pattern only, like radiation pattern with spacing d is equals to lambda by 2 into radiation pattern with spacing d is equals to lambda by 2. So if you multiply this radiation pattern 2 times, you will be having same radiation pattern. Let me note it down. Resultant pattern is unit pattern of X or Y into group pattern of X and Y. Here, see unit pattern of X or Y. Unit pattern of X or Y. So X is a combination of 1 and 2. Y is a combination of 3 and 4. So unit pattern of X and Y, X or Y, that is happening as per d is equals to lambda by 2. And group pattern of X and Y, so that is having spacing d is equals to lambda by 2 again. Right. And one should know with lambda by 2, radiation pattern is having nulls at 0 and 180. So you will be multiplying this pattern 2 times. And if you multiply these 2 patterns, then null locations are there at 0 and 180 only. Right. So here, after multiplication, nulls are there at 0 and 180 only. So maxima into maxima, that is resulting into maxima only. And with this, we don't have any minor lobes, right? So here you see spacing is d is equals to lambda by 2, and here spacing is d is equals to lambda by 2. So here, if you talk about what will be electric field, then electric field with spacing lambda by 2, that is this. So if you multiply this electric field 2 times, it will be cos square pi by 2 cos theta, right? So for three elements, current distribution will be 1, 2, 1, and electric field will be cos square pi by 2 cos theta, right? That is how it is happening as per this explanation, right? Where, see, current distribution, that is 1, 2, 1, that is happening as per 1, then 1 plus 1 means it is 2, and here it is 1. So in total 4 elements were there, but after clubbing this 2 and 3 together, we have only 3 elements, right? That is how radiation pattern is happening with binomial array. Now I'll explain you 4-point source using binomial array. So in that, all you need to do is you need to club 2 patterns. See here with 3 points, we have this, right? With 3 points, we have this equivalent. So if you wanted to have 4 points, then all you can do is you can club 2 combo of 3 points. So here you see we have I, 2I and I, and another combo that I am taking, you can observe, that is having current I, 2I and I. So if you club these two, then if you talk about this combo, then that is I, 2I, I, that is having this radiation pattern, right? And this second I, 2I, I, that is having also same radiation pattern. But if you talk about this group A and this group B, then you see here middle of group A, that is happening somewhere over here, and middle of group B, that is happening somewhere over here. So this is A and this is B, and spacing between A and B, that is lambda by 2 only. See, that is lambda by 2 only, right? As with these elements, spacing is lambda by 2, right? So if you multiply this pattern A and B, then you will be getting resultant pattern. And here pattern of A, that is I, 2I, I pattern, right? So that we have derived over here. I, 2I, I pattern that we have derived over here, right? So you just need to multiply unit pattern of A into group pattern of A and B. So unit pattern of A or B that we have seen, that is this. Let me take it again. And group pattern of A and B, that is happening as per spacing D is equals to lambda by 2. See, group pattern of A and B, that is having spacing lambda by 2, right? So that is this pattern only. Let me plot it again. And if you multiply these two pattern, you will be getting similar pattern again, where angles are there at 0 and 180 degree with nulls. And if you multiply maxima into maxima, here only we will be having maxima. So that is how we will be having similar radiation pattern as per spacing D is equals to lambda by 2, right? Now here, if you talk about what will be the resultant current distribution with 4 points, then you see here resultant current distribution with 4 points, that will be happening as per algebraic sum of currents. So with this first element, current is I. With the second element, current is 2I plus I, that is 3I. With this element, I plus 2I, that is 3I. With this element, current is I. That is how binomial array is having non-uniform current distribution. And here spacing between elements, that is lambda by 2 only. Remember this, it is lambda by 2 only, right? That is how one can form binomial array. And with binomial array, current distribution is non-uniform, and here we have no minor lobes. You can observe this resultant radiation pattern, that is having no minor lobes. Now I'll explain you Pascal's triangle to form binomial array. See, I have already explained you how it is happening, but still you need to understand this. With one element, we have 1. With 2 elements, this one and this one that is coming over here. With 3 elements, this one is coming here, this one is coming here, and this element is sum of these two. The reason is this is there in contact with this 2 hexagon, so you'll have to add this 2, and that is 2. Here we have 1, here we have 1. This hexagon is in touch with this 2, so 1 plus 2, 3. And this hexagon is in touch with this 2, so that is 2 plus 1, 3. Here we have 1, here we have 1. This is there in touch with this 2, so 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. And that is how you can have further elements, right? So that is how one can have Pascal's triangle to form binomial array. And these numbers are current distribution with elements that one should know, right? Now let us discuss about parameters of binomial array. So there can be question like, what is the total length of binomial array? So if you want to calculate total length, then spacing between elements is lambda by 2. Spacing between elements, that is lambda by 2. If you have 4 elements, then lambda by 2 into number of element minus 1. So lambda by 2 into number of element minus 1, that is what total length of binomial array. So that is lambda by 2 into n minus 1, that is total length, right? If you want to calculate half power beamwidth, then you'll have to remember this equation. See, that is 1.06 divided by square root of n minus 1, where n minus 1 is how much? That is 12 by lambda, right? So if you substitute square root of 12 by lambda over here, you will be having 0.75 divided by square root of L by lambda, that is half power beamwidth of binomial array, right? And if you want to calculate directivity, then basic equation is 1.77 into square root of n, and this n that can be identified from this equation itself, where I have substituted n is equals to 1 plus 2L by lambda as per this equation. See, this 2 that is getting multiplied here, lambda is getting divided over here, and after that you will have to add 1 over this side, so that will be n. So n is 1 plus 2L by lambda that I have substituted in this equation to get directivity, right? So these are the essential parameters that one should know for a understanding of binomial array. I hope you have understood this. Still, if anything that you would like to share, just note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.